Okay, we've talked previously about the origins of the periodic table, where it came from or how it was developed. I want to get into a little bit of the specifics on it today. So as you look at the table, and I'm just going through the Wikipedia page here, there's a lot of really nice stuff here. And this particular one is nice because it's interactive. When you scroll over certain elements, it'll show you a picture of the element and give you some detail on it, which is kind of nice. But this original table here, this table that you see, is arranged, and you've got these nice color codings to show you some of the different groups or families. And I want you to know the parts of the table. First of all, understand that we call the vertical rows groups. So this is a group, group, and so forth, coming up and down. Sometimes they're also referred to as families. So this could be, the alkali metal family or alkaline metal group. You could refer to it either way. And again, what's going on here, and the reason they're grouped together is because they behave in a similar fashion. This chapter, we're going to talk about the electron arrangements of the elements as well. And what you're going to learn is that every element in this family has one outer electron, and that's why they behave in a similar fashion, and that's why they're grouped together in a family. So we kind of talk about these things together as we go through this. So the red ones here, or salmon, whatever you want to call that, those are called the alkali metals. They do not include hydrogen. Notice hydrogen is a different color. It's considered to be a gas. Hydrogen is a gas that you probably know. So in some ways it might behave as though it belonged over here in the halogen family because it's one away from a full shell. The first electron shell only holds 2 electrons. So while hydrogen has 1 valence electron like the alkali metals, it's actually a non-metal that's one away from a full shell, just like the halogens, the group 17 halogens over here. So in some ways it belongs here, in some ways it belongs here. So it's an exception. Hydrogen is an exception to so many things because we're filling that first group, which only hold, or the first electron shell, which we'll talk more about later, which only holds 2 electrons. My second column is the alkaline earth, and that's this family here. The columns over here, the noble gases, are these light blue guys over on the side, and they are very non-reactive, which I hope you know from prior experience. The halogens, which are column 17, very, very reactive non-metals. In fact, fluorine is one of the most reactive non-metals. 16 called the chalcogens, and these are the pnictogens. Again, you never hear, rarely do you hear, pnictogen is very unusual. I don't hear that very much at all. Chalcogens I hear from time to time. The ones you really ought to focus on are alkali metals, alkaline earth, halogens, and noble gases. Those are the 4 family names that are most common. These 2 are out there. Now, as far as the numbering, they do number the groups, so they can talk about the group 1 elements, the group 2, the group 3, and so forth. They also sometimes will simply call it the carbon family or the boron family. So they could say the group 13 elements, they could say the boron family, but that's all referring to this column here. The horizontal rows are called periods. The periods actually include these guys down here at the bottom, and you'll see this little star means that this group goes right in there. This 2 stars means this goes here. But writing it out like that, you'd have to make this so wide. Most often by convention, they simply pull these elements down and put them in the lower part. Now, a couple other things you should be aware of, some common names. This middle area from column 3 over to 12 and down, these are generally known as the transition elements or transition metals. These down here are sometimes called the inner transition metals down here in the bottom. The first row of these inner transitions begins with lanthanum. So these are sometimes called the lanthanides, and you'll see that indicated down here. And this row here is sometimes called the actinides. So those are 2 rows that have distinct names because they're unique and they kind of belong down here. You'll see some of those other names I mentioned, the alkali metals, alkaline earth, the lanthanides and actinides we just talked about. The transition metals, again, are that whole center area. You have this post-transition. That's not a common term, but again, sometimes these are metals, and you get some unusual behaviors here. There's a stair-step line, and I'm going to show you more about this in a minute or two. There's a stair-step line that goes along here, and this divides your metals from your non-metals. Everything to the left of this line is considered a metal, except for hydrogen. Everything to the upper right is a non-metal, and that would include hydrogen. The things along that line, which are indicated here with this sort of, I don't know what color you want to call that, kind of an olive green color, those are considered your metalloids. They have properties of both metals and nonmetals. And then you have your noble gas name here as well. So now let me slide down and show you some of these other things I've talked about. You'll see again, here's another indication. Here's some of these group names I've told you, the boron group, the carbon group. Again, there's other names like this, the tetrals. You rarely hear these sorts of things. The coinage metals, again, is not something you'd hear very much. The name, the IUPAC name is 1 through 18. They just number those columns 1 to 18. There are older designations, which you may come across from time to time. In the United States, they used to refer to column 1 as 1A, column 2 as 2A, Group 3 as 3B. The problem is, you'll see here in Europe, they refer to 1A as 1A, 2A as 2A, but they call what we call 3B, they call 3A. So there was some confusion there. So now it's just the more common and more modern way of referencing these things. It's just these numbers, the 1, 2, 3 over to 18. And then again, you'll see some of these other names. And again, here are your metalloids in this kind of an olive green. Here are your nonmetals, your halogens, and so forth. So you've got a lot of that sort of thing going there. Now, here's this business with the different parts of the table. And let me kind of see if I can slide this over. Yeah, I can slide this a little bit. If I come over to the left, you'll see column 1 and 2 are also referred to as your S block elements. I'm going to talk a little bit about electron configurations, and that is why they are referred to as your S block elements, because you're putting electrons into the S block, and I'll explain that as we get into the electron configurations. The blue area, which is columns 3, and notice there's a gap between 3 and 4, and then you've got 4 through 12. These are your transition elements or D block elements. These are your lanthanides and actinides down here. Remember, I told you a moment ago that they actually belong up here, but to make this a little less wide, they oftentimes pull those down here. But notice they really should be inserted after group 3 and before group 4. Again, they are called the F block elements, and I'll refer to that more later, but we're putting electrons into the F block, F shells. Here we're going to be doing into D, so you'll see that it's called the D block. And then over here on the right-hand side, you will see the P area, which is columns 13 over to 18, and you'll be putting them into P sublevels. And again, I'll explain all that SPDF down the road, but I'm just trying to have that make a little bit of sense to you now, or give you a little bit of forewarning on what's coming. And again, here's another way of looking at this metal non-metal business. Again, all of these sort of yellowy, greenish yellow, whatever color, these are your metals. Notice most elements on the table are metals. The blue are your nonmetals, and these here are your metalloids, or sometimes they're called your semi-metals. There's some trends there. We'll talk more about trends later. The other thing I want to mention is a lot of times on these tables they do something to let you know the physical state of the element. In this one they change the color of the number. If it's red, it's a gas at room temperature and pressure. So notice most of these nonmetals, or many of these nonmetals, are gases. If it is blue, the number is blue. No, it's this greenish color, I'm sorry. These are your liquids at room temperature. It looks a little more green to me. So again, you'll see the mercury and your bromine. Those are your two liquids at room temperature and pressure. And the black would be a solid at room temperature and pressure. And again, you can see it's a little bit confusing here because these elements keep popping up. But it is nice with this table because you can see the different elements.